So today we are going to do cross sections, which is very similar to what we did yesterday, except we're doing triangles and semicircles. The big thing on triangles and semicircles are the formulas. The integral is going to be the same thing. It's still the integral from a to b, a of x being your area function. Alright, so a of x is still your area function of the cross section, and then perpendicular to x would be in terms of x, perpendicular to y would be in terms of y. So all of that's going to stay the same. Now we have three different shapes that we're going to talk about today. We have equilateral triangles, isosceles triangles, and semicircles. Alright, an equilateral triangle looks like this, kind of, sort of, where all of the sides are the same, because that's why it's called an equilateral triangle. Well, what is the formula for area of a triangle? 1/2 base times height. Well, the problem here is that the height is not the same thing as the base. So you do some geometry magic, and it is going to end up with this area equation, where this guy right here is your side. Now, I could show you the geometry magic that gives you that equation, but it's not super helpful, and it's better to just remember square root of 3 over 4, side squared.
Okay.
But if you are interested in knowing the geometry magic, I can show it to you.
Because 4 of those make like a square, I thought we have to do side square. We're good.
It's got something to do with the 30, 60, 90 triangles
Yeah.
back in the, figured you'd be okay with not doing that. All right, and so then when you are using your cross sections, your side is going to be the top minus the bottom, and that's going to give you your side length. So let's go back to my visual here. Whoop. Go away, semicircle. Hold on, we have to reload it. I don't know what it is about this class. There it goes. Okay, so if you look at your cross section, do you see how the top minus bottom gives you one of your sides? You know what I'm saying? So the area is going to be square root of 3 over 4, and then top minus bottom being squared, and then as you take this to infinity, it's going to give you that little shark fin that we saw yesterday with all the bajillion little triangles in it. Make sense?
Yeah.
Okay. Then we have isosceles triangles. What does isosceles mean?
It's only 2 equal sides.
2 equal sides. And so what it's probably going to say on the AP test is it'll say an isosceles right triangle, which means that your 2 equal sides are going to be formed with a right angle. And so when you are doing your formula, 1/2 base times height, well, your base and your height are going to be the same, which is where you're getting this formula right here, 1/2 side squared. Your side is still going to be represented by top function minus bottom function. And then the last one here is we have semicircles. All right, so ooh, that looks really bad. What's the area of a circle?
Square.
And so because this is a semicircle, that's where the 1/2 is coming from. So the half is because it's a semi. Now on your little formula sheets, I did something kind of weird. And instead of writing pi over 2 r squared, I wrote pi over 2 d over 2 squared. Now what do you think that d stands for? Diameter.
Yeah.
All right, because diameter divided by 2 is the same thing as radius, right? So on your formula sheet, I wrote pi over 2 and d over 2 squared. And the reason why I wrote it like this is because almost everybody without fail forgets to divide by 2. Now let's look at the visual, maybe. stop spinning on me. Okay, that's a pretty good visual. So if you look at your semicircle here, if you do top minus bottom, do you see how that gives you the length of the diameter? So when you're writing this equation, pi r squared, or pi over 2 because it's a semicircle, so pi over 2 r squared, your top minus bottom has to be divided by 2. And everybody forgets to divide it by 2. They do top minus bottom because that's what you do on everything else, including revolving, including area between two curves. This is the only thing that you have to remember to do top minus bottom divided by 2 because your radius is half of that. Does that make sense? So that's why on the formula thing I did d divided by 2 to remind you, oh, if you're doing semicircle cross sections, you need to divide your top minus bottom by 2. And so this guy right here is your semicircle area. All right, so we've got 3 examples. I've got 1 of each. And then that's it for today. So in example 5, it says find the volume of the solid whose base is a region bounded by the graph y equals the square root of x, y equals 2, and the cross sections are perpendicular to the x-axis and are semicircles. All right, if it doesn't give you a graph, I would go ahead and sketch one. So what does the square root of x look like?
Kind of like this.
Line.
Yeah.
Just a line.
And what does y equals 2 look like?
A line at 2.
Vertical or horizontal?
Horizontal.
Horizontal. So I've got a horizontal line right here at 2. And so the region bounded is going to be this guy right here. All right, the region bounded by those 2 lines. All right, now it says that I am perpendicular to the x-axis, which tells me that I'm going to be this way. And my guy's going to be in terms of x. So I'm going to draw my line to show top and bottom. And I know that everything has to be an x bound. So we're going to end up having dx. So when you're doing your bounds, and I kind of noticed this on your test, it has to be an x bound. So your bound is not going to be from 0 to 2 because this is a y number. So everything has to be in terms of x. So I know I'm starting at 0. What is the x number?
4.
Yeah, 4. Because when you set the square root of x equal to 2, you get x equals 4. So you got to find your x bound. So we're going to go from 0 to 4. And then I'm going to do my area equation. Because all that has to go inside this integral now is your area equation. So for a semicircle, that's going to be pi over 2. And then I'm going to write d over 2 squared. D being the diameter, which is top minus bottom. All right, so looking at my line, what is the top function?
Y equals 2.
2 minus, what's the bottom function?
Square root of x.
Square root of x. And I need to divide that by 2 because
It's the diameter.
it's the diameter. And now this is my area equation. All I got to do is take my area equation, put it inside my integral, and then I can type it in and figure out what my volume is. What you will see a lot of times on some of these equations is they'll pull out the coefficient. So what is the coefficient on this one?
2.
More than that. Well, I guess what's an easy coefficient to pull out?
-1.
This one, pi over 2. So I can pull the pi over 2 out here, and then I can just have this whole thing in parentheses in here.
Why would you do that? Is this not going to have calculator sections for some of these?
If you were on the non-calculator and you needed to integrate, it's easier to pull that pi out and not worry about it until the end.
That seems like
If you were, you don't have to pull the pie out. It just helps, I think, with integrating to not have to look at it. You could leave the pi over 2 in there.
does it not want us to solve or?
Oh, we can type it in. 1.047. I'm gonna solve one of them today. Like all the way through. I'm not gonna solve that one though. That one's kind of icky to solve. Okay. So let's look at 6. It says find the volume of the solid whose base is the region bounded by the square root of x again. All right. And x equals 5. So square root of x looks like this. X equals 5, is that going to be vertical or horizontal?
Vertical.
Vertical. At 5. And so this is my region here that I'm bounding. And am I going to be in terms of x or in terms of y?
Wait, why'd you write square root of 5?
I don't know. Because it's 8th period on Thursday. There we go. Thank you. All right, perpendicular to the x-axis. So I'm going to do my little line right here, going straight down to the x-axis so I can see my top and my bottom. And now I need to come up with my area equation, which is going to be equilateral triangles. So what is the area equation for equilateral triangles?
Square root of 3 over 4.
And S is going to be your top minus bottom. It's going to be that little distance of the line that I drew. So square root of 3 over 4, what's the top function?
Square root of x.
Square root of x.
Which is x.
Yeah. Minus the bottom function is going to be 0. Anytime you hit the axis, that's going to be 0, which is going to be squared. So do you really need the minus 0?
No.
No. And what happens with the square root of x squared?
It just turns into x.
It just turns into x. All right, so that's my area equation, which I'm going to put in my integral. So my integral is going to be from what to what?
0 to 5.
0 to 5. So 0's there, all the way to 5, which it gives me, which is nice. If you want to, you can pull out the square root of 3 over 4. You don't have to, but it's a constant coefficient, so we can pull that coefficient out. And then we just have x that we have to integrate. So this one's pretty easy to integrate. What's the integral of x?
5.
What?
X squared over 2.
Sorry, x squared over 2.
X squared over 2?
I don't know what I was thinking. The base.
From,
It's 8th period.
it is
8th period on a Thursday or whatever.
From 0 to 5, which one do you plug in first?
5, 25 hours.
25. And then I've got square root of 3 on top, and then 4 times 2, which is 8. And then when you plug in 0, what do you get? Just 0, so this would be your answer. So I'm not saying like you're never going to have to integrate these guys, but if you are going to have to integrate them, a lot of times it's not a super complicated integration problem. And the ones that are really complicated integrations will be like set up but don't solve. Or set up and then type in your calculator. All right, so let's do the last one. Now on your paper, I changed it to be isosceles, so we could do one of each. Bless you. So we're finding the volume of a solid whose base region is between these two lines, F and G. So I'm going to draw my graph. All right, so F is 1 minus x over 2. So what would the y-intercept be?
1.
1. And is my slope positive or negative? Negative. So it's going to kind of go something like that. That was a really bad line. That was a little bit better. All right, and so then for G, what's my y-intercept of G?
-1.
-1, and my slope is? Positive. So that's going to go something like this. So that one's G, this one's F. And so my region, which is bounded by these two graphs here, is going to be this region right here, this little triangle. We don't have to stop at the x-axis. It's just the region that's bounded by those two lines. All right, so isosceles, which is what area?
1/2.
S squared.
And for the S, that's going to be top minus bottom.
F of x
Yep, so that's going to be f of x minus g of x. So top function, which is f, bottom function, which is g. Now this is your area equation. We have to figure out the bounds and figure out like the actual interval that we would type in.
2 and negative 2, or that 2 is not
Well, are we in terms of x or y?
x.
X, so we need x bounds.
Yeah, 2, right?
This is 2, but what's the first one?
Oh, 0.
0.
That's fine.
And to find that 2, you're setting these guys equal to 0, or not equal to 0, equal to each other. Oh my gosh, we're almost done. Equal to each other, and but also you can kind of visually see, just knowing like how slope works, rise and run, that they'll hit it too. But if you can't see that, like graphically, if you're like, I'm really terrible with graphs, you just set the 2 equations equal to each other to find the intersection. All right, so my bounds are from 0 to 2. This is my area equation. If you want to, you can pull that 1/2 in front. Do you have to? Absolutely not. You don't have to. And then the f of x minus g of x. Ugh. Close squared. And then, as some of y'all saw on the homework quiz, just make sure your squared is on the outside of your entire parentheses. Like, you need parentheses around everything, so just be careful when you're typing it in. And when you do type that one in, you get 8/6. You could work it out by hand. We probably don't have enough space right here. Is that okay? Kind of make sense? All right, so that's basically it for cross-section. So we're done with cross-sections. So the last thing we have to do is revolving, and that is the last topic. We're going to do 4 days on revolving. Not that we could get revolving done in 2 days, but we're in, you can kind of do cross-sections in 1 day. But
Let's do that in 2 days and then have 2 free days.
2 days for cross
No.
sections, right, Aaron?
we have 0 free days.
Literally the same thing. Not in calculus.
Not in calculus. So we will start revolving next week, which revolving is fun. So.